All right, good afternoon. Thank you for joining me. Yes, this talk is called Smooth Operator. We're going to talk about HashiCorp Vault and Kubernetes operators. Quick show of hands, who's now got that song stuck in their head? And who's got no idea what I'm talking about? Yeah. Okay, my name's Ric Featherstone. I'm head of engineering at Control Plane. And I'm going to talk about how can we do secure self-service administration for HashiCorp Vault. We want to make Vault administration like a vending machine. So this is administration. This is not about consuming the secrets. This is about how we create those secrets engines, how we hook up the authentication methods, and how we can do this in a secure manner that's easy for our consumers. So some of the things that we're talking about is secrets engines, authentication mounts, and policies. The Vault APIs themselves cater for a wide range of use cases. We want to remove the need for our consumers to be Vault experts. So we want to provide opinionated configuration, restricting some of the options so that we can ensure consistent use and compliance with enterprise policies. We also want to capture ownership and entitlement metadata that's not possible with the Vault APIs. We want to control access, restrict the ability to create and use policies so that we're doing that in a secure manner. We want to prevent drift and do all of this securely. So what I put to you is that we need a service layer wrapping the Vault APIs. Okay, not exposing those Vault APIs directly, but putting something in place, restricting the options, setting those defaults. And we need platform capability. So it's not just your favorite web API framework. We need certificates so that we can expose our service layer over HTTPS. We need an identity provider and access control so that we can control who can create the secrets engines, who can create the authentication mounts. We need to store our desired state, and we need a scheduler so that we can detect drift and correct it, and also for periodic updates. And we need a metadata store for the who owns these mounts and who's got permissions to use things. So now we step into the sort of operator space. So what is the operator framework? Everybody here probably, quick show of hands, who knows about operators? Who's using them in the wild? Okay, so controller pattern. So at the core of Kubernetes are controllers watching changes to Kubernetes resources, moving the current state towards the desired state. And that's the core Kubernetes APIs. Now we can extend that by creating our own custom resources and registering those in the Kubernetes API. Your types define your desired state, the things that are important to you. And by doing that, you get a new endpoint with CRUD operations for your resources. And then if we look at the documentation, we can see some of the common features for custom resources. So we get the CRUD endpoints added to the API server. We get HTTPS. We get authentication, authorization. Finalizers allow us to clean up external resources before our custom resources are deleted from the API server. Owner references enable us to garbage collect Kubernetes resources. So if we got a Kubernetes resource, our controller creates another custom resource. We can set an owner reference on that. So when we delete our original custom resource, Kubernetes will clean up the other ones for us. And by defining these custom types, we can attach the metadata that we need for reporting. So all the extra things that we need from our previous slide. And the operator pattern is just kind of pulling this all together and automating that operational knowledge. And the operator framework itself is just one set of tools that are around sort of building, managing, and discovering operators. There are alternative frameworks around for building operators, but the operator SDK is the one I'm most familiar with. So we'll start with a concrete example. So if we want to provide AWS credentials to infrastructure as code running infrastructure as code pipelines running on Kubernetes. We need AWS secrets engines, and we're going to use the Kubernetes authentication method. So it gives us something to focus on, but these concepts can be applied to all of the secrets engines and auth methods. So we've got some various teams involved. We've got an AWS IAM team. They will be provisioning the AWS IAM, and they need to be able to configure Vault to vend AWS credentials. We've got our Kubernetes cluster admins. When they provision new Kubernetes clusters, they want to configure the Kubernetes authentication mount. And then we've got the app teams who will be consuming these. And so when they start to deploy their apps to a new Kubernetes cluster, they want to create roles, map in their service account, the namespace, and the policies that they want to use. And then we've got kind of enterprise policies. So when we set up the AWS Secrets Engine, we want to rotate those credentials immediately. And then we don't want those fixed credentials sat there for a long time. So every 30 days, we'll rotate those credentials. Vault's only going to provide access to assumed role credentials. So we're going to create a role for each application and map that through. And each application is going to have its own IAM role. So what does this look like as a suite of operators? So we've got 3 operators there. A policy operator, that's creating the policies. And then we've also got this policy request custom resource. So if you want to attach a policy to an authentication method, we want to check that you're allowed to use that policy. So for setting up the AWS Secrets Engine, we've got the AWS Secrets custom resource there for setting it up. And then we create the roles on there with another custom resource. When we create a role, we know that we want to be able to read those AWS secrets. We don't need to write to them. It's just a read-only secrets engine. So we can create that policy whenever we create that role. We create that read policy for it. And then Kubernetes auth can be used by the cluster admins to mount that authentication method. And then when the app teams come along, they can create a Kubernetes auth role on there, add in the policies that they want. And we'll create a policy request at that point, which allows us to check that you're allowed to use the policies that you're asking for. So we'll have a look at that in action. And like all good cowards, I've pre-recorded this. So we'll start off with AWS Secrets Management. Okay, so I've got nothing up my sleeve. The only policies we've already got there are the ones for the operators, and we've got one for the Secrets Operator client because we're going to encrypt the credentials using the Transit Secrets Engine. And we've got no secrets already created there, so we'll create an AWS Secrets Engine, and that looks like that. So we're encrypting the credentials, we're capturing the owner metadata and the region that we're going to make the STS calls against. And in the status of that custom resource, we can see that it's been mounted, it's been configured, and we've rotated those credentials. And we can also track from that the time that those credentials were rotated. So periodically, we can rotate those credentials again. And then we'll have a look. So we can now see that the AWS Secrets Engine is mounted. So if we now go and create a role on there, and we're mapping the application ID to the role that we want to assume, and then if we have a look at the status of that, we can see that we've created a policy, and we've created that role on the secrets mount there. And we can see the name of the policy down at the bottom there. And if we have a look in Vault, we can see that policy's been provisioned and created in Vault. And then if we have a look at the custom resource itself, we can see where the grantees are the applications that are allowed to use it. It's a read for the path to grant those secrets. And then we can see, with the owner reference there, we can see why we've created this policy. It's linked to that AWS Secrets role and the name, and that allows us to clean up those policies when that role is no longer required. So now let's set up the authentication, Kubernetes authentication. So we've got an authentication mount already. That's the one the operators are using. So we'll create another one, and that's it's running on the same cluster. So we just need to provide the API address there. Have a look at the status. We can see that it's been mounted and configured, and then we'll list it. And we can now see we've now got a Kubernetes authentication mount in there. So now we'll create a role on there. So it's the application that we're using, so we can check against those policies, the namespace, the service account name, and some TTL information. So we have a look at the status of that. We can see we've created the role, but we've also created that policy request. And then if we have a look at that policy request, so can this application use this policy? And then we'll have a look at the status of that custom resource, and we can see that's been approved, and we can see in the list of approved policies, we've got the policy up there. And then from the metadata, again, we've got that owner reference, so things will be cleaned up. And we can also use that for reporting, so that we can find out who's using stuff and why. And if we have a look at the role in the vault, we can now see that that policy has been applied with the service count that we specified. So now just to kind of demonstrate in a bit more detail that policy request control. So we'll delete that role on the AWS Secrets Engine first. And because of that, that owner reference, that will automatically delete the policy custom resource. So that's gone, it's no longer there. So now nobody can be authorized to use that policy. And we'll have a look in Vault, the policy's now gone. And then if we look at the status of that policy request, we can now see it's no longer approved, and we can see the list of unapproved policies there. And if we have a look at the role itself in Vault, we can see that policy has now been automatically removed from that role. So that gives us, same sort of thing would be performed up front. So we're checking whether you're allowed to use the policy, and if you're not, you can't get it. If you are, you will get it. But if that permission is removed at a later date, the operator is reconciling that and will remove the policies. So you could leave the policy in there and just flag it as unapproved and then monitor that and check on it, or you can take it away like we've just seen there. And that's it. So yeah, key takeaways, think about what you expose to your customers, make it simple to consume. I think that's kind of one of the key things for putting that service layer in front of there. Taking away some of the confusing options so that consumers don't have to be Vault experts, making it nice and easy for them to consume. If you need to capture metadata, you've either got to spin up a database, if you're just doing it with a web framework, or if you're using operators and custom resources, then you just get that for free. So yeah, operators provide a lot of those cross-cutting concerns out of the box. The reconciliation loop, it's constantly checking, making sure that the state is as we expected it. If I deleted that policy from Vault, well, I've still got that policy custom resource, it'll be recreated. So that allows us to automatically detect that drift and correct it. Owner references help with the cleanup. When I removed that, the role from the AWS Secrets Engine, the policy was automatically removed. And we can use the state of the resources for reporting. And that's it.